There is a metal quietly present around you right now, on someone's wrist, in a neighbor's smile, on the head of a golf club in a garage. And it was once used to help the United States secretly peer into the Soviet Union during the Cold War. Ironically, the Soviet Union sold it to the US at a dirt cheap price, thinking the Americans were just buying it to build pizza ovens. That metal is titanium. So what makes it so light, so strong, and so valuable that it has transformed industry, medicine, and even modern history?
Welcome to Secrets of Everyday Things, the channel where everyday secrets are uncovered and explained.
It sounds like a James Bond movie, but this is the true story of titanium, the strangest metal humanity has ever gotten its hands on. It is stronger than steel, almost half the weight of steel, does not rust in seawater, does not cause allergies in the human body, and when it gets scraped on a golf course, it throws off sparks at 3,000 degrees that can set dry grass on fire. In California, investigators have officially traced a handful of real wildfires back to titanium golf clubs. It is the only metal where you can walk into an MRI machine, with an enormous magnetic field humming around you, and the titanium pin in your hip stays exactly where it is, like nothing is happening. And yet, this superhero metal was first discovered by an English parson, wandering a remote stretch of coastline in Cornwall, picking up black sand for fun. In 1790, William Gregor, half-country priest and half-amateur mineralogist, noticed that the black sand he had collected contained a strange oxide unlike anything he knew. 4 years later, a German chemist named Martin Heinrich Klaproth independently rediscovered the element, and he was the one who gave it the name titanium, after the Titans of Greek mythology, the giant suns born from the earth itself. The name sounded heroic, but the joke was on humanity. We would need another 150 years before we figured out how to pull it out of a rock. The reason is simple and extremely annoying. Titanium is the most stubborn element on the periodic table. It is the 9th most abundant element in the Earth's crust, more common than copper, zinc, and lead put together. Under your feet, inside the pebbles at the beach, inside the dirt in your garden, titanium is everywhere. But you cannot just walk up to a mountain and pry off a shiny lump of pure titanium the way you would lift a nugget of gold or copper. Titanium clings to oxygen. It clings to other elements, like a toddler who refuses to let go of a parent's leg. To get clean titanium, you have to force it to let go. And that step is so energy-hungry, so time-consuming, and so expensive that for most of human history, it just was not worth trying. In nature, titanium hides inside two main minerals called ilmenite and rutile. Most of them come from massive open-pit mines in Australia, South Africa, and Canada. There, the excavators are the size of 2-story houses, and the ore is scooped up, crushed, washed, and sorted, ton by ton. When you look at that pile of dark reddish-black powder, it is almost impossible to imagine that hidden inside is the very material that will someday fly into orbit and live quietly inside the chest of a heart patient recovering from surgery. The real story of titanium production begins with a man named William Justin Kroll. In 1932, in a laboratory in Luxembourg, Kroll was trying over and over to find a way to separate titanium from its compound, without poisoning the final metal. He tried calcium first, then he switched to magnesium. By 1938, he had produced 20 kilograms of ductile titanium, shiny enough and strong enough to convince him the world would need this metal one day. But the world was not listening. Not until World War II ended, and the aviation industry suddenly needed a metal that was both light and able to handle punishing heat, did anyone bother to walk back into Kroll's laboratory and say, "Thank you." In 1945, not a single factory on Earth was commercially producing titanium. 10 years later, the yearly global output was 25,000 tons. Very few industries in modern history have exploded that fast. And it all happened because of a single procedure called the Kroll process, named after the man who invented it. The Kroll process is still the backbone of the global titanium industry today. And it is also the reason titanium hurts your wallet every time you buy something made of it. The Kroll process begins by mixing titanium ore with chlorine gas and a source of carbon, usually coke. Then everything is heated inside a large reactor to about 1,000 degrees Celsius. At that temperature, the chlorine devours the titanium and produces a fuming liquid called titanium tetrachloride. Meanwhile, impurities like iron, silicon, and calcium settle to the bottom of the reactor. That liquid is then distilled to clean it, the same way people distill moonshine out of rice wine back home in the countryside. But nobody would want to drink what comes out of this particular still, because one whiff of it in the open air can melt your eyeballs in seconds. The next step is where the chemistry goes completely wild. Workers pour the titanium tetrachloride into a sealed chamber holding molten magnesium. All of it is surrounded by a perfect vacuum, or inert gas. And then they wait. When the two substances meet, they react violently. The magnesium shoves the chlorine aside, and what gets left behind is pure titanium metal, curled up into a spongy gray-silver mass that you can actually crumble in your hand. That spongy lump sounds ridiculous when you describe it, but it is the raw source of every airplane, every submarine, and every titanium hip socket in every human being on the planet. But titanium sponge is not usable right out of the reactor. It has to be melted down again in an extreme vacuum furnace, using a method called vacuum arc remelting, or VAR, or a method called electron beam melting, or EBM. In these methods, the metal is bombarded with plasma or electron beams until it flows like honey. This melting step does more than just smooth the sponge out. It is also when engineers drop in the extra ingredients that create alloys. Add 6% aluminum and 4% vanadium, and you get Ti6Al4V, the most common titanium alloy in the world. The same material that lifts every Boeing 787 into the sky, and the same material that carries the dental screw implanted in the back of your mouth. Once the molten metal cools into big blocks called ingots, the factory rolls them, forges them, stretches them, and squeezes them into sheets, rods, and tubes. This is also where titanium shows the second reason humanity finds it annoying. Titanium is hard. It is tough. It does not conduct heat well. So every time you try to drill it or shave it on a lathe, the cutting tool heats up fast and dulls fast. Machinists who work with titanium often joke that cutting it is like trying to carve frozen chewing gum with a cheese knife. You need special blades, special coolants, special machines that weigh more than a pickup truck. And of course, you need a very deep wallet. This is where the Cold War story I opened with finally starts to make sense. In the 1960s, when Lockheed's legendary Skunk Works engineers were ordered by the CIA to build a spy plane that could fly faster than 3 times the speed of sound to photograph Soviet missile bases, they hit one very uncomfortable problem. At those speeds, the friction of the air on the airframe generated heat that would melt aluminum like butter. And only titanium could survive it. Unfortunately, the largest supplier of high-grade titanium on the planet was the Soviet Union, the very enemy they were trying to spy on. The CIA solution was something straight out of a spy novel. They set up a web of shell companies in third-world countries. They bought Soviet titanium, claiming they needed it for pizza ovens, bicycle frames, and cookie molds. And they shipped it quietly back to the United States, where it was forged into the Blackbird, the most famous reconnaissance aircraft in history. The Soviet Union supplied the raw material for the plane that photographed its own territory for years, and it never knew. That story is true. It is recorded in multiple declassified documents, and it remains one of the most elegant pieces of deception in the entire Cold War, all thanks to one slippery piece of metal that might be sitting on your wrist right now, as a sports watch. Away from the battlefield, titanium has a second life inside hospitals. There is a small biological miracle that happens when you screw a titanium pin into human bone. The bone does not treat it as an invader. Instead, the bone grows around it, fuses to it, locks onto it, a phenomenon scientists call osseointegration. That titanium screw becomes a real part of your body, almost like a new tooth rooting itself in. This is why millions of Americans are quietly walking around right now with titanium dental implants, titanium hip joints, titanium knee joints, titanium spinal screws, even titanium pieces inside their hearing aids, and titanium stents inside their blood vessels. You can walk through airport security with titanium inside you, and the detector barely grumbles compared to steel. You can lie down for an MRI and trust that the titanium pin in your body will not get yanked out by the magnet. That one property alone has rewritten modern medicine. And then there is the prettiest magic trick of all, the one anyone who has ever owned a titanium earring or a titanium watch secretly loves: rainbows. If you dip a piece of titanium into an electrolyte bath and send an electric current through it, the surface will grow a thin oxide layer, thinner than a strand of spider silk. So thin you cannot see it with the naked eye. But that oxide layer bends light in a very particular way. A ray of sunlight hitting the surface reflects twice, once off the top of the oxide layer, and once off the titanium underneath. And those two reflections interfere with each other to produce pure, saturated colors that look almost too clean to be real. Gold, pink, violet, cobalt blue, peacock green. Every shade shifts depending on the exact voltage used. This is the same reason the soap bubbles you blew as a kid shimmered with every color of the rainbow. Except titanium does the same trick permanently, frozen on a piece of metal. It is not paint, it is not plating. It is the actual surface of titanium humming in color. These days, with industry largely locked into the aging and energy-hungry Kroll process, scientists are testing a newer method called the FFC Cambridge process. It uses electrolysis to pull titanium directly out of the ore inside a bath of molten salt, the same way aluminum has been produced for a century. If it ever scales to industrial size, it could make titanium 1/3 as expensive as it is today. But for now, William Kroll is still winning, 70 years after his death. Most of the titanium on this planet is still being produced by the exact recipe he worked out in a small Luxembourg lab before World War II, following the same steps he once scribbled down on paper. More importantly, even though titanium takes a staggering amount of energy to produce, it happens to be one of the friendliest metals on the planet when you look at its entire life cycle. A titanium hip joint can stay inside a human being for 40 years. A titanium airplane wing can fly for 20 years, come down, get melted back down, and fly again. Silver, copper, and aluminum can all be recycled, but few metals retain almost their entire original property profile after remelting the way titanium does. A broken golf club becomes a bicycle frame. A worn bicycle frame becomes a turbine blade, and the cycle just keeps going. So the next time you slide on a titanium wedding ring, the next time you glance at a SIN or Citizen watch on your husband's wrist, the next time you hear the faint click of the titanium screw the surgeon bolted into your spine 3 years ago, the next time you watch a movie about Cold War pilots flying silently over Moscow, or just pick up a golf club and breathe in the smell of cut grass on a Sunday morning, remember that you are touching a story nearly 300 years long. From an English parson picking up black sand on a remote beach, to a Luxembourg engineer stirring molten magnesium in the dark years before the war, to the blackbirds slicing through Siberian skies in total silence. All of it is folded into one silver-gray piece of metal that the ancient Greeks never got to see, but named anyway. And named correctly: Titan, son of the earth.